There is a lot of talk going on this aspect of chips and how rare earths are affecting the chip manufacturing, how we are being affected, how much of chips India is importing, and the cost of those imports, and that goes into everything. An EV car requires a chip manufactured abroad. We don't have the chip capacity. And we are looking at making India by 2030, we are looking at an EV India. And we are looking at electronic India. So when we look at the chip concept, it is a very, very difficult progress we are looking at. For example, I would like to give some statistics based on that. Very recently, I think Tatas are willing to invest about approximately 1.2 lakh crores to set up a semiconductor chip manufacturing unit somewhere in Maharashtra, if I'm not wrong. Now, let me give you some statistics on chip manufacturing, from which we will be able to understand where we are and where we stand with regard to chip manufacturing. Now, silicon is one of the most abundant materials available in the world, and a chip is made out of silicon, and it's called a wafer because wafers are thin slices of semiconductor materials used in electronics to manufacture integrated circuits. The diameter of a silicon wafer varies from 25.4 mm to 150 mm, and thickness from 10 to 10,000 microns. I hope we get the picture of it. The diameter is approximately 25.4 mm, millimeters, and the thickness is 10 microns to 10,000 microns. And how much is 1 micron? 1 micron is 1/26,000th of an inch. 1/26,000 of an inch is 1 micron. So 10 microns multiplied by 10, you still don't reach it. A figure is mind-boggling. You're not able to understand how much it is. That is the, what do you call it, the thickness of the wafer. That is how you operate a chip is put into it. It's not a bulky thing. It's available so small, and you fix it into your telephone, you fix it into your EV car, you fix it anywhere, wherever you're using electronics. You have it, that chip. And that is the size at which the chip has to be manufactured. Now, how much of power it requires? Requires power for continuous manufacturing is looking at 20 gigawatts. That is how much of power you require to manufacture. 1 gigawatt is equal to 1 billion watts. 1 gigawatt is equal to 1 billion watts, which is equal to 10 crore kilowatts. Now, that is the kind of power you require, 1 gigawatt. So, when you look at 20 gigawatts, you multiply it by 10 crores. So, that is the amount of power we have to have in India to support a silicon man. And that is what today, I think 2 days ago, our visionary CM of Andhra Pradesh, Mr. Naidu, has projected that he wants to develop, not powered by coal or by, he wants energy which is available like solar or any other type of green energy to the extent of 20 gigawatts. So you can look at the extent of his forethinking, because that is how, unless we enter into that area, we will not be able to manufacture chips. Again, cost of setting up a 3 nanometer chip fabrication unit is $15 billion to $20 billion. 8,000 crores, I would say today 9,000 crores is equal to 1 billion. That means you can imagine what is $15 billion. About 200,000, about 120,000 to 180,000 crores is what you're looking. You understand? So that is the amount of money we require to set up manufacturing a 3 nanometer chip fabrication unit. Again, The cost of manufacturing one 3 nanometer chip wafer is equivalent to $20,000 to $25,000. One 3 mn nanometer chip. And the chip's yield will be approximately 50% in the initial stages and 70 to 80% when it's fully mature. That means you can get the maximum 80% of your capacity of your chips when you manufacture, not more than that. Imagine how much of chips you require to manufacture in the electronics that we use in India. I don't know how many chips are used in a car, in an EV car. I do not know, maybe one chip, but I'm sure it must be more than that, or it must be a more powerful chip. I do not know about it. I would like to give the information later on that. Water consumption is 1,500 to 2,000 gallons of pure water to manufacture a chip. 1,500 to 2,000 gallons. If you look at it, in Indian things, 5 gallons, 5 liters to a gallon. That means 10,000 liters you require approximately to manufacture it. That's the amount of water, pure water which you require to manufacture. So what is the amount of water which we should have? Do we have that kind of source of resourceful water? We do not know. Where they are going to resource this water, where they are going to get this pure water available. Are we going to have desalination and then realkalining this water to make it available like a well water, pure water available for flow? I do not know. That is what we are looking at. That is what India is looking at. And we are not such a mature economy. We don't have, I do not know whether we have so much of funds. The government is looking at 1 lakh crore only for R&D, only 1 lakh crore. To set up a chip plant, you are requiring how much? 1,20,000 crores for one chip plant. For one R&D, you are able to get only 100,000 crores by the government. So where are we going to get this funding? Do we have the resources? Do we have the people to back us up? No, we have to look at it. Again, to manufacture a 3M chip, a minimum highly qualified engineers required. And to manufacture for a whole plant, you require about 3,000 to 5,000 engineers. Do we have that specialized talent to manufacture that? I do not know. Because most of our people have been trained to do, posting and to operate a computer. Our no-go with regard to the development of software, we know about it, what we have developed as software. I don't think so. We have a single software comparable to Microsoft or to what is available with Google. We cannot develop one single AI by ourselves. We just follow. So when we start R&D and we are going to look at new specialty items, the quality of engineers has to change. We cannot have this run-of-the-mill engineers. Do we have that quality available in India? That is another angle which we have to look at chip manufacture. And then the largest semiconductor manufacturing in the world. Number one, NVIDIA. Its turnover, $4,558 billion. The next one is Qualcomm. The second one is Samsung, approximately $413 billion. Samsung is 413 and NVIDIA is 10 times of Samsung. Samsung is supposed to be a leading supplier of phones and TVs in India. And that is 10 times less than NVIDIA, a chip manufacturer. And we have Qualcomm, which is approximately $182 billion. So, in the world market, where are we with regard to industry, especially the chip manufacturing industry? We are nowhere. Therefore, comparing it to my previous video with regard to the SLR, our economies are not sufficiently so powerful and so strong. For chip manufacture, we have to do so much to achieve our goals. And that means to set up, for one unit, we require so much of investment. and we require a lot of R&D to develop it for our, environment, our systematic operations, and our talented, what you call jugadis. They use it for so many aspects. All that has to be covered when we manufacture our chip. So I think we are not even taking the baby steps with regard to chip manufacture. We are on a very, very low scale when compared to chip manufacture, and we should await I would say the turn of another couple of 2 to 3 years for us to reach at least some level of chip manufacture and our economy to grow. Thank you.